PCBWay reached out to me and they asked if I want to do a collab on a project. I decided to design an LED panel. So they sent me the PCBs. It happened really fast. I was super impressed with the speed. It looks something like this, and I'm going to walk you through the process. You can order the PCB yourself if you want. I guess that's it. Let's get into it. So, first thing you need to do is obviously order the board. So, I've already logged into PCBWay, so create an account if you haven't done that. Where you want to go is shared products, or shared projects rather, which is there. And this is where there are all kinds of open source shared products that people have designed, that PCBWay have made, and that you can download, or, well, yeah, you can actually download files, but also you can order the PCB, or you can even order the PCB assembly where they actually populate the PCB with the components as well. So you can have it fully made for you. Now, in our case, we're looking for the dimmable LED panel. You can see in my case, I've looked it up already because it suggested it, but it'll be new for you, of course. Enter, and it comes up right away. And you can see Sizer, that's me, obviously. Click on it. It shows you, obviously, the image. Here's a picture of the silk screen. You can download the Gerber bill of materials, I believe. You know what? I'm just going to click on this and see what happens because I've never done it. Oh, yeah. All right. So it downloaded the bill of materials. Cool. All right. If you want to purchase it, you can select only the PCB or the PCB plus assembly. You can donate if you want to be kind and support open source. And here you can add to cart. The turnaround is crazy fast. From the time that I sent it to the time that it was in my hands was definitely less than a week. It was a few days. I was shocked, actually, that it came all the way from, I don't know if it's Shenzhen or Hong Kong, but anyway, it's in China, and I had it in less than a week. Something I want to show you too that's really cool. If we go back, I'm just going to pull up some of my orders. Let's just pull this order up. When you look at your orders, there's just production tracking. That button goes live right away. And what's really cool is each of these steps gets sort of updated as they happen. So you can actually, once you send your order, you can come and look at your production tracking, and you can see at what stage your order is in the production process. So that was really cool. Okay, so let's close that and let's move on to the actual building of the board. Okay, so we'll start with the USB socket. This is just a standard USB-A socket, 4-pin. Here we're just gonna bend over these, I don't know if you call them pins, but anyway, these little posts here on the side. Those aren't electrical connections, but they are important, though. They create rigidity for the part, so that when you're plugging and unplugging your USB connector, you don't eventually cause metal fatigue in the electrical pins. Moving on to the MOSFET. Now, all you have to know for this is that there's a gate, drain, and source, and make sure you get them right. So look at the way I've got it installed on the board. Now we're moving on to the 3-ohm resistor. This 3-ohm resistor is a 1/2 watt. That's important. If you use a 1/4 watt, it'll get too hot. The 1/2 watt allows it to dissipate the heat that it's going to need to dissipate to not burn up. This is just a little bit of a current limiting thing to take up some of the voltage that isn't dropped across the LEDs. The 10 microfarad capacitor, that's just a filter capacitor for the whole circuit. It's an electrolytic capacitor. Notice there is a negative symbol on the capacitor. Make sure you check. Don't just follow the colors and see on the board, well, I see it looks black on this side, and maybe the capacitor looks black on that side. Verify, because the colors vary from capacitor manufacturer. So make sure you line up the negative side on the actual capacitor with the negative symbol on the board. The 1 nanofarad ceramic capacitor, They don't all look the same. See in the diagram, I've got one of these little flat, dark sort of orange ones. In reality, what I'm actually using is one of the yellow ones that are a little more bulbous in shape. They're both ceramic capacitors, doesn't really matter. And they're not polarized, so there's no positive and negative, so it doesn't matter which way you put it in. Of course, you do have to make sure that you're not confusing the 1 nanofarad with the 0.1 microfarad or 100 nanofarad, which is the next one we're about to install here. Here's the 100 nanofarad or 0.1 microfarad. Notice that the 1 nanofarad was marked 102 and the 100 nanofarad is marked 104. I did find it a little tricky for some reason. You wouldn't think it would be too hard to line up the legs to get them into the holes on the board, but I actually had some trouble there with that. So if you're having some trouble, it's not just you. Okay, moving on to the NE555 555 timer. So this is what they call an IC, an integrated circuit, which just basically means it's a bunch of different little components all sort of etched into one little component. Dual inline package, which is this sort of format and size. Notice how you determine pin 1. So on an IC of this type, on a dual inline package, or DIP, you might say, you've got that little notch. I see I've got them in yellow. There's either a little notch or a little dot. I don't know if I've ever seen both or not, but you're going to have at least one of them. And so the pin to the left of that dot or that notch is going to be pin 1. And then notice my little diagram. So then from there, you just go 2, 3, 4, and then you go across, and then you resume from there, and then you continue counting upward in the other direction. And that's the standard way to count pins on all DIP ICs. So it's not this pin configuration is not unique to 555 timers. If you had an op amp in the same package, a little 8-pin DIP like this one, or even a 24-pin DIP that looks like this, but it's 24 pins instead, that's standard. So always to the left of the notch or the dot is pin 1, work your way down, and then skip across, and then work your way back up in the other direction. All right, the rectifier diodes, there are 2 of them, the 1N4001s. So notice there's a positive and a negative side, right? An anode and a cathode. See how I've lined up the symbol with the illustration of the diode? Make sure you follow that on the board. So on the board, you'll see the symbol is drawn on there in the silk screen. So make sure that you line up that horizontal line on the tip of the triangle. That represents the cathode, where the white line is on the actual diode. So make sure you line those up correctly. Potentiometer, they're not polarized. It's basically a resistor with a wiper, it's called. So it allows you to sweep from one end of the resistor to the other. So it allows you to increment the resistance all the way from minimum to maximum. Just make sure you put it in the right way. Okay, turning the board over. Everything seems to be holding in place. Now, sometimes things do fall out. You may make an effort to splay the legs, but some things, like for example, see how loose this pot is, the potentiometer? It's common for that to drop out. So sometimes you have to maybe put some tape on the backside just to hold some of the components in place until you get them soldered. In this case, I managed to get it done, but don't be too discouraged if you're finding it just keeps falling out. That's normal. Just put some tape on it to hold it in place until you get at least one of the legs soldered. Now, I'm not going to go into solder technique here because I think it'll make too much for one video. In the comments, let me know if you want a solder practice or a solder technique video, rather. I can do it. But I think for this video, we'll just stick to how to build it and assume that you've got a little bit of soldering practice or know-how. If you don't, I mean, you can learn something here just by watching me. Notice how I'm not using very much. So this is for people who don't actually know how to solder yet. Hey, no shade. That was every one of us at one time. So something to notice is I'm not using too much solder. More importantly than that, something that most people tend to get wrong initially is they don't understand the importance of applying the iron to both the component leg and the pad so that both heat up, and then not applying solder until they're both already hot enough to melt the solder. You're not trying to sort of melt the solder and have it drop onto the component. That will never work. You need to heat the component and the pad fully, and once they're both hot enough, once they've reached a temperature where they'll melt solder, which is about 375 degrees, then you touch the solder against the component and the pad, and you try to sort of direct the solder so that it touches both of them, so that it kind of flows onto both the component and the pad, because you do need it to do that. And so, you don't want to sort of direct the solder in such a way that it's only making contact with the pad or only making contact with the leg of the component. Once we've got all these pieces soldered in, then we go back and clip the legs off. Don't clip too close. Don't try and get it perfectly flat against the board, so that when you snap the side cutters closed, you're not pulling on the component and you're not pulling on the board. These legs on the USB port or socket, you really have to make sure you heat them. Give them some time to heat up. You'll find that if you try to apply the solder too quickly, it just won't melt, because the body of that socket becomes like a big heat sink, and it draws heat out of the iron, but it dissipates it quickly over that large body size. So you'll notice you'll have to hold the iron against those legs significantly longer than you do pins from the components, just because those legs will wick heat away. Is wick the right word? No, not dissipate heat. And that whole metal body of the socket is like a big heat sink. Okay, I would say the most important part of this, or the most tricky part of this, it's not tricky, but it's important to get this right. Notice there's a flat side on the diode. It matches the flat side in the component drawing right on the silk screen. It's also the shorter leg. That's the cathode. That's the negative side. You want to make sure you line those up properly. If you put it in backwards, it won't light up. You won't damage the circuit. It's not like you're going to blow anything, but you won't get anything lighting up if you get them backwards. So make sure, if you feel, depending on how good your eyes are, you may or may not be able to see it, but if you look down at the LED, you'll notice there's a flat side. So like I said, match that up with the flat portion of the drawing of it on the silk screen. And then here, notice I'm testing after I get one in. I don't want to go any further, because I don't want to spend, an hour or two soldering all these LEDs only to find out the whole thing doesn't light up. I'd rather know now, after I got one in, so that I can start troubleshooting before, putting all that time in and then feeling discouraged. And then I'm going to test each row as I complete it, because again, it's just so much time spent soldering these things in. It's 110 of them. It's quite a bit. It's a real drag or it would be a real drag to solder all 110 and then plug it in and nothing happens. Again, it's not like you'll damage the circuit. You won't even damage the LED, in fact. If you put it in backwards, it just won't light up. Let's say, hypothetically, you got all of them in correctly except one. Maybe you accidentally reversed one. They'll all light up except that one that you reversed. So you'll know right away when you, like, if you test a full line, say you do a whole row and 2 of them don't work, then it's almost guaranteed, it's almost sure that it's just that they're in backwards, because if it were something else, then it's likely that the whole row wouldn't work at all. Splaying the legs on the LEDs was kind of making it difficult to solder them. They weren't lining up nicely. So I decided to instead apply some tape to hold them in place while I solder the legs. I also found that some of them didn't sit nice and flat against the board. After soldering and, flipping it over and pulling the tape off, I noticed a few of them were a little bit proud. They were not sitting nice and flush against the board. So I had to sort of put my finger on top of the LED to apply some pressure downward on it, and then apply heat with the iron on the underside to both pins at the same time, so that both pins became loose. And then by put my finger on the top side, pushing down on the LED, caused it to drop flush against the board. And then I removed the iron from the pins at that point, and then the solder re-solidified, and then that's how I got everything to sit nice and flat, because a number of them were not sitting nice and flush against the board. So that's the whole process. Again, we've got a row done, so let's make sure we test it before we go any further. And voila, the whole thing works nicely. Brightness control seems to work. All you have to do is carry on as I'm doing here. Once I get this second row soldered in, I'll flip it over, test it again. And then once you have all the LEDs installed, then you should be good to go. Thanks for watching. Extra special thanks to PCBWay for sponsoring this project. I guess that's it, and I will catch you on the next one. Thanks, guys.